Okay, so again, we are on our 2.5 notes. We're on the back side of our notes. We have two proofs there. We worked one of them together yesterday. I want to take a look at the second one. Okay? Anytime you are writing a proof, you always want to kind of try to think ahead first. Okay, you always want to think ahead. So I'm just going to look at this diagram and read what they give me. They give me that line segment AB is congruent to line segment CD. And they have that marked in the diagram. They want me to somehow prove that line segment AC is congruent to line segment BD. Now, are we talking about numbers right now, or are we talking about things? Things, because it's congruent, right? Not equal. So we got to somehow compare things. Now, maybe we have a way of comparing numbers and things. Maybe we have definitions in things that allow us to do that, to know certain things. Okay? But refer back to the proof that's right next to it. It's talking about angles. But it's kind of the same concept as what we're doing here. AC is that line segment. BD is that line segment. Any ideas how we might go about this guy? Okay, so we're going to run this proof very similar to what we did yesterday. It's going to be slightly different because we're talking about congruence in our proof rather than equality. But we still need to have our same setup. It's a two-column proof. So give yourself two columns to work with. First column is your statements. Second column is your reasons. And our first statement is always what's given to us. So my first statement should be that line segment AB is congruent to line segment CD. That is given. Okay. So we said in our little discussion here that we actually want to be working with equalities, right? We said that, hey, we know the two line segments are congruent, therefore we know they're the same length. How do we know that? We know that AB equals CD. Notice how I changed the notation. I no longer put bars over the top. Why? Because what does AB stand for? It is a number. And what number does it talk about? The distance from point A to point B. AB talks about the distance from point A to point B. So how do we know they have the same length? Nope, not substitution, not the angle or segment addition postulate, none of that stuff. I told you what congruence meant. We had a definition of congruent segments that said if two segments are congruent, they have the same length. Right? Well, that's it right here. That's our reasoning then. Definition of congruent segments. We know that if two segments are congruent, we know they're the same length. Okay, well next, just like we did in yesterday's proof, so look back at yesterday's proof, how are we going to go about saying something else? Because remember, we want to eventually talk about line segment AC, right? And line segment BD. So how are we going to go about doing that now? Any equations we could write? Any postulates that are on the board that we might be able to use? I'll give you a hint. We are going to be looking at either this guy or this guy or this guy or possibly one of those, but probably not.
For like the equation or whatever, would you write segment AB plus CD equals AC plus BD?
Nope, because that's something we don't quite know yet. We wouldn't know that yet. But we do know that we can use what postulate? You had said it. The segment addition postulate. We can use the segment addition postulate, because remember, we want to talk about line segment AC. Well, then what can I say about AC? I know that AB plus BC equals AC. Right? Isn't that our segment addition postulate?
Yep.
All right, well, I can do the same thing, and I can either do it in a second step, or I can do it all in the same step, because it's all for the same reason, right? I'm going to go ahead and do the same thing for BD. So I know that BC plus CD equals BD, and both of those are for the same reason, the segment addition postulate. Okay, so we now know information or equations involving our segments we're working with. So what we need to do now is think about how are we going to get these segments to be what we want. How are we going to get these equations to be what we want? So again, what are we trying to prove? We are trying to prove that line segment AC is congruent to line segment BD. Yes?
Would you do like AB plus BC equals BC plus CD?
Okay, we got to be careful. We do not already know that AC and BD are equal in length. We don't know that. We're trying to prove that, right? So what we do know, though, is that AB is equal to CD. Is there any way to manipulate these equations so that I can say that AB equals CD? Again, refer back to yesterday's proof. We did one very, very similar to this yesterday. It was the same concept, only it dealt with angles rather than line segments. What do we think? I'm going to do the subtraction property. What am I subtracting from my first equation? The BC. If I subtract BC from both sides, I get that AB equals AC minus BC. What am I going to subtract from my second? I'm still going to subtract BC, so I'm going to end up with CD equals BD minus BC. And that was from our subtraction property of equality.
You put BC minus BC.
I did, thank you. That should have been the BC. This one is BD. Thank you. Okay. So we now have that. Well, the great thing is I can now take this expression and substitute it in for AB in that equation. And I can take this expression and substitute it in for CD in that equation. So I am now saying that AC minus BC equals BD minus BC by substitution. Yes, ma'am. Yeah, go ahead. What do we do next?
You're going to add BC to one of the sides.
Oh, not just one of the sides.
So you're going to move it over.
Nope. I'm going to add BC to both sides, which is what you're getting at. But you can't say it to one side, because if you do it to one side, you have to do it to the other side. That is the rule or the property of addition, right? So, yes, we're going to add BC to both sides of this equation. I'm just going to show my work here by saying, okay, well, if I add BC there, I've got to add BC there, and then what happens? Well, the BCs cancel out on both sides. And so we get that AC equals BD, and that was because of the addition property of equality. But wait a minute. Look at what we have written down here. AC equals BD. Is that what we were actually trying to prove? No. We were trying to prove that line segment AC is congruent to line segment BD. So we have gotten to the point where we've proven they're the same length, but are they congruent? What? Say it
We
again?
need to use the definition of congruent segments.
That's exactly it. We've got to use the definition of congruent segments again. We know that AC, line segment AC, is now congruent to line segment BD because of our definition of congruent segments. Gosh, dang it. Having a hard time with that today, apparently. Line segment BD. There we go. And so there we go. There is our proof. Okay. Are there questions on this? Now again, is every proof going to be like this, where you're using the segment addition postulate or the angle addition postulate? No. But that's why it's very important that you read through all of your postulates and read through all of your definitions so that you know what tools you have to work with when you're doing these proofs. Because today's homework, you will have, let's see, a bunch of the problems are going to be just using what property says this. And you're just filling in the blank like you did yesterday. Okay? But then you're going to have two problems where you're writing the whole proof. Now, are they both going to be 7-step proofs or 10-step proofs or 12-step proofs? No, they might be 2-step proofs or 4-step proofs. But you have to write the complete proof. Okay?